Okay, we're going to go ahead and get started. Thank you for joining us today for our webinar on an insider's guide to Groovy 4. I'm Jen and I work with the 2GM team here at Object Computing. We are pleased to have Object Computing's Groovy practice lead, Paul King, here, sharing an overview of the exciting new features you'll find in Groovy 4. We will do a live Q&A session at the end to answer as many of your questions as time allows. So as a reminder, please load up your questions into the Q&A section as you have them. We are recording this session and do plan to make it available to view on demand. I think that's it for me, Paul, so I'm going to turn it over to you as I know you're eager to get started and have a lot to cover.
Thanks, Jen. Welcome, everybody. It's Friday morning here in Brisbane in Australia, 6 o'clock in the morning, so a nice, bright, inspirational start, and that's a good place to be for talking about Groovy 4. It's a nice, fresh, new version of Groovy that we've got ready for you, and so welcome to this talk on behalf of Object Computing and the whole Groovy community. So what's the state of play with Groovy in terms of its health and where it's heading and so forth? It's as popular as it's ever been. So it's just clicked over the 1 billion downloads earlier this year. Half of that has been in the last 12 months, so 500 million downloads for the current 12 months up to now. So it's growing as that number is growing every year. So it's being used more than it's ever been used before, which is great. In terms of Toby rankings, the Toby ranking, the Toby index has got a few flaws with it. It tends to be a little bit erratic. Things jump around a little bit, and there's a few flaws. If you've got a language that's not very well documented, you'll get lots of queries in Google about it. Whereas if you have lots of good documentation, you'll get less queries. So your ranking will go down. So there's flaws with the index. But the good news is that Groovy's sort of hovering around the top 10. It peaks into the top 10 every now and then, but it's been very close to that, averaging about 11 or 12 over the last 12 months. So that's all good. So Java's at position 3 at the moment. It's usually in position 1 or 2, but it's Python has sort of been slowly moving up the ranks. And that's also good news for Groovy, because Groovy's kind of the Python flavored Java, if you like. But there's other languages around, so it's a great time to be on the JVM. We've also got Kotlin and Scala and Clojure all in the sort of 30 to 50 top rankings as well. So there's lots of things to choose from. Activity is healthy and steady. So that's a little picture of the Groovy code base over time. So when we go and do some sort of refactorings, you see sort of ripples that appear through there. But on the whole, there's quite a healthy continual progress of the source code. 500 contributors, so thanks everyone who's contributed to Groovy. We certainly welcome anyone who has got some ideas they want to share or code. Please come along to the project. Greater than 200 releases. We just had a bunch of releases about a week ago. And so we're expecting Groovy 4 to soon go into the release candidate phase and then be available for GA. So we're kind of just waiting on feedback on the latest set of releases. And also we're just letting the dust settle now that Java 17 is there. We fully support Java 17. And we're just sort of waiting for any bugs that surface when people are starting to use that in earnest. Service will make any quick fixes we need, and we'll get a version of Groovy 4 out not too far down the track. We'll wait till it's, we reckon it's very solid, and then we'll get it out. So what's in Groovy 4? I won't talk to every bullet point on this slide. It's a little bit noisy, but this is sort of what we're going to cover today. There's a bunch of consolidation and structuring changes. So they kind of a little bit boring, but it's kind of good to know about some of them, because otherwise you won't know where to find Groovy. And you won't know some of the implications of things that are done. So we'll cover some of that first, and then we'll get on to some language features, which is kind of the shiny new bells and whistles. And then there's other new bells and whistles in libraries and tools, and some ASTs and so on, so AST Transforms. So we'll get on to all of that. So we'll start off with just the consolidation and structuring. And we'll just dive in and get into that. The good thing is with all these additional bells and whistles that you're seeing added to the language, because of the consolidation that we've done, the actual zip is a third smaller than it's ever been before. And the core jar is 10% smaller as well. So you're going to get more features and it's going to be streamlined, a nice slimmer download, which is always good to see. It doesn't happen very often because normally we're adding more and more features, but we've done a bit of cleaning up here. So Groovy 4 really sets us in a good place moving forward. So the first thing is the Maven coordinates changed. So this is where you go and look up the Groovy jars in a Maven repo. So if you go and look up under org codehouse Groovy, you won't find Groovy 4 there. Don't worry that we've stopped working on the project. It's all under org Apache Groovy. So if you go look under org Apache Groovy, you'll see it. Now, some people have thought that we've gone and changed all the package names of internal classes. That's not necessarily the case. We've been changing org codehouse Groovy as a package over to org Apache Groovy for numerous years now, and we just do that in the background for new classes that get introduced, but we haven't gone and changed legacy classes. Most people, when you programming in Groovy, will be using the groovy.xml or groovy.util or whatever packages anyway. So you probably won't see the package name changes that's mostly going on behind the scenes. So if you just to recap, go look in org Apache Groovy now for all of your Groovy jars. Now, Groovy comes in a bunch of modules. They're, for the first time in Groovy 4, they're very close to full-blown Java modules. They don't have the module info in them yet, but there's no longer any issues with split packaging and all other sorts of things. So we'll talk more about that on the next slide. So what's happened? Groovy BSF, the Bean scripting framework, is something that predated scripting, JSR 223. So we've phased that out. You can still go get the jar out of Groovy 3 and use it with Groovy 4 if you're really desperate. We had a very small number of bells and whistles added to JAXB, but the sort of JAXB support in the base JDK is sort of been a little bit problematical. So we've phased that out, and again, you can go get the jar out of Groovy 3 if you really need that functionality. There's 5 new modules. There's a contracts, there's a language integrated query thing, there's extra macros, TOML, parsing and building support, and some optional type checkers. And just a very minor change, if you're using the Groovy All POM or BOM, Groovy Test NG used to always be included in that. It's now an optional one, so it's no longer in the Groovy All. And Groovy YAML for parsing and building YAML is now included in Groovy All. That was the most widely used module that everyone sort of wanted out of the box, so we made that slight tweaking. If you want to avoid being subjected to that slight tweaking, we don't do it willy-nilly, but you can always go and just use all the core jars directly, and you won't ever have to worry about being impacted by little changes like that. Okay, so that's the changes. There's 30 modules, 5 new ones. A couple have disappeared. So that's the sort of grand picture of modules. Now, inside the modules, there's also been a little bit of coalescing of things. So one of the issues with Java modules, and we're trying to be compliant with all of the Java module system, is a split packaging requirement. And when Groovy originally did all of its modules, that requirement wasn't around on the JVM scene, so we didn't abide by it. So in 2.5, in the Groovy XML module, there was Groovy util XML parser, for instance, as well as Groovy util used in the core jar and other places. So in Groovy 3, we moved all of those classes over to Groovy.xml inside the Groovy XML module. We left the original ones around to assist with porting. With Groovy 4, all of the old legacy package names have all gone. So it's safe to move over to the new ones. You can do that anytime during your the lifespan of using Groovy 3. And when you're ready, it'll be, once you've moved over, you'll be fully ready to just jump straight onto Groovy 4 without any issues. Okay, so I've shown a Groovy XML example. They're the 2 impacted classes in Groovy XML. There's a handful in Groovy Ant, Groovy Swing, Groovy Test, and so on. So if you're using the Groovy test case, the sort of Groovy 3, JUnit 3 compliant sort of test class. It's got a few bells and whistles in there that some people might use. If you're using that, go and change your package name when you're importing that. Otherwise, if you're using JUnit 4 or JUnit 5, you won't need to make any changes. Now, with Groovy 3, we introduced a new parser. It's the parser that lets you do Lambda expressions and so forth. We left the old parser around, and you had a little switch. You could switch back to the old parser if you needed to. The feedback that we've got is that everyone, they want us to see if we can do a few performance tweaks to the new parser, but otherwise they're very, very happy with the new parser. So in Groovy 4, we've removed the old parser. And Groovy's done a lot of work in the past, making very, very efficient class caching and so on for doing all of its dynamic invocation of methods on your behalf, what the Groovy runtime does. And with the invoke dynamic support that started in sort of Java 7 or JDK 7 levels and was improved in JDK 8, invoke dynamic support allowed us to do some of that in a more efficient way. And initially that was a little bit buggy, the invoke dynamic support in early versions of JDK 7. So we kept both around, and you had a switch. You could switch between the two. Now we're indie only. Okay, anywhere where there was any reason why you'd want to stick with the classic, we've now improved. We've made it more performant, and indie is all you can get now. Now, just a tiny, for someone in the know, if you're worried about legacy classes that might have been compiled under the classic JDK, all of those classes are still there. They're just not used. And in fact, there is a very small number of places where we actually fall back to those classes, but you don't, it's all invisible to the user. And over time, we'll get rid of a few little cases where we still fall back to classic. Good news is that you'll be getting improved bytecode going forward, and Groovy 4 has got most of that in place already. Okay, so that's just sort of the consolidation, and so it was all a sideways shift in many ways. Most Groovy users, all of that's not going to impact how they make use of Groovy. It's just putting Groovy in a better place. So let's look at the bells and whistles, language features. First cab off the rank is switch. I changed the order at the last minute. I'll do this one first. Language integrated query. Now, normally there'll be a tiny bit, there's a GQ bracketing scheme that's around all of this. I've just left that off to fit everything on the slide. So this lets you do, this is using memory collections in this case, but you can use it with XML or JSON or whatever you might have as well. And it lets your code for manipulating those collections look like SQL code. So if you've used JAOQ or use language integration query in C# or F#, you'll understand what this is about. So this is a way of interacting with a collection in a way that would be familiar to someone who's familiar with using SQL to interact with the database. So that's the sort of style that it lets you do. It's sort of a little mini DSL, if you like. Behind the DSL, there is a full API so C#, if you go and look at its documentation, you'll see there's a complete API there as well. We have all of that, but I'm just going to show you the sort of the friendly DSL that most people would typically use. Yeah, and yes, there's been a comment. Thanks, Daniel's son. Daniel is the key inspiration behind that change, and others as well. The Parrot parser was Daniel was a big player in that as well. So thanks very much, Daniel. The next thing I want to talk about is sealed types. So this is all about something. So Scala has sealed types, Kotlin has sealed types, and Java 17 has got sealed types. So what's sealed types all about? It's all about giving you more control over inheritance hierarchies. So inheritance is this very, very powerful mechanism. Now we know with anything that's powerful that if you go a bit overboard, you can run into issues. So there's the whole use delegation over inheritance in certain scenarios. We're not worrying about that. This is all about controlling the inheritance hierarchy. And so I've got a base class shape here, and I might want to create an inheritance hierarchy with a square and a circle. They're two shapes. And at the moment, I can make shape an interface, or I can make it a class. I could make it an abstract class. I can make square and circle. I can make them final, which stops further inheritance or not. So I've got very, very, very crude ways of controlling the inheritance hierarchy. Basically, I can put a final in somewhere in the hierarchy and it stops all further extensions. But in this case here, if the shape class is public, so if I did this in Java and it was public, I can't stop other people extending that shape and doing other things with it. And there's various tricks I could do. I could put a package private constructor inside shape and so on. There's tricks I can do to control it, but it's not a very elegant way of controlling that hierarchy. So there's scenarios where limiting the inheritance has benefits. So often if I'm creating an inheritance hierarchy in my parent classes, I'm writing code that's a little bit defensive. So I've got code, well, if I've got a square, I'll do this. If I've got a circle, do this. Or if I find something else, throw some sort of runtime exception. I don't know how to print a shape of some other type. If someone makes a triangle and in the base class, I had a thing for printing shapes, and triangle isn't in there, and the person who created the triangle hasn't offered any mechanism. Maybe that's not part of the abstraction that my hierarchy is supporting. I'll throw a runtime exception or something like that. So I tend to write very defensive programming in my parent classes. I can't do compiler checks if I've got a cast that says if this shape is an instance of triangle, because I don't know whether triangle might be some class that extends shape or whatever when I'm compiling up the shape class. So there's various kinds of compiler checks. If I'm doing pattern matching, I want to do exhaustive checking. There's a whole bunch of additional things I could do if that inheritance hierarchy was controlled in some way. And as I mentioned before, the existing mechanism is very crude. Basically, I've got all or nothing inheritance, and the package private parent classes. If I use some of those tricks, I don't get a good abstraction for a list of the parent classes and things like that. That parent class might not be visible, or if I make the constructor package private, there's other limitations. So at the moment, it's sort of very, very crude. And what seal types, they give me a way to provide a fixed set of children. So it's not all or nothing. It's, yes, you can extend this, but only with a known set of classes. So this decouples the accessibility of the parent classes from the extendability, okay? And if you're using a sealed hierarchy, it's easy to add new methods because I know what all, if I add a new print this shape method, I'll know what the entire list of shapes are. So I can go and do like a switch statement with this. If it's a circle, if it's a square, if it's a triangle, I'll know how to print that shape out. So it's easy to add new methods, but it's hard to add new types. If triangle wasn't there and I've gone to add a triangle, all my existing methods, if there's like switch statements in all of those, I might have to go and add a new triangle case branch in every single one of the switch statements for every existing method. So seal types, when I want to add new methods, not new types. If that's the kind of scenario I find myself in, a sealed hierarchy is a good way to go. Unsealed types is where I do want to allow new shapes to be added. So I want to allow people to add triangles and diamonds and stars. In that case, it's very easy to add new types. But if I want to go and add a new method, then all of my classes will be impacted. I'll need to go and change anything that might extend from shape or whatever, if I want to add a print this shape method. But also all people who are other users of my class that might have extended me, they'll also be impacted. So it's a bigger issue to add new methods in abstractions where they're unsealed. So it's not a one's better than the other. It's different scenarios will lend yourself to go one way or the other. Java's introduced this as a very, very useful mechanism. So we're supporting it as well. Now, we support two different styles. This is creating a sealed class. And this is showing the annotation style. I imagine many of you won't use this style, but I'm just going to point it out because it provides us with a mechanism to allow us to support this back way to JDK 8. So it's not just a JDK 17 thing for us. But also it would allow us to give minimal functionality a bit if we backport just that annotation back to a Groovy 3 perhaps, then we'll have a way to create sealed types back in Groovy 3 land, but not the compiler back in Groovy 3 land won't do anything special for you, but you'll be able to create types. And if you create them, you'll have to manually create them in the right way, but then they'll be potentially workable inside Groovy 4. If you create a library or something in that you want to be Groovy 3 compatible, you could go create that, use the annotation, and it'll be forward compatible with Groovy 4. So here we've created a shape class, and we've said the only things that can inherit from shape class are diamond and circle. So that's what the permitted subclasses annotation attribute is there. So we can now go and add a diamond class and it can extend shape, a circle class can extend shape. If we go and do another shape, we do triangle now, that'll be a compile time error. Okay. And I've shown this for a class, but it could work on an abstract class as well. Now, most of you will probably use the keyword, the sealed keyword as shown in this example. So this is exactly to mirror what Java does. So that's using the, and that's on a trait. So as well as working on classes, it works on traits. And as you'd expect, it works on interfaces. Now, if you compile all three of those classes, so polygon, square, and rectangle, if they're all in the same source file, you don't need to have the permits clause or the permitted subclasses annotation attribute. So it'll infer what all of the subclasses are, and it'll automatically put those in for you. Okay, so that lets you create that those three classes, and that's a sealed hierarchy. So we've got three sealed hierarchies there. One for shapes, one for triangles, one for polygons. Okay, now this mechanism is very good for abstract algebraic data types, abstract data types. And the nice thing in Groovy land is that so I'm creating a tree node, and I might use singleton for empty nodes. I might use canonical or immutable or whatever for different parts of the nodes. And then I can go and make use of that. And it's a sealed hierarchy, put all that in the one source file. And I've got a nice algebraic data type with lots of nice properties, and I can make use of that. So I just had a question. I was going to take questions at the end, but while we're on sealed types, it's the same compilation unit. Is that right? No, same. I think it might be. I'll have to double check on that. I think it's the same compilation unit. No, it's. Yeah, it's if it can't find it during the compile, it's going to complain. I can double check on that. Okay, now there's also a notion of non-sealed, and there's both an annotation and a keyword for that as well. And that's where you want to have control over part of the hierarchy, but then you want to make a certain part of it uncontrolled again at some point. So here we've got a shape that permits three so it permits circle, polygon, and rectangle, so three subclasses. If you like, they're three branches of subclasses. So the circle branch, it's a final class, so that stops that branch. So we jump down to circle and stop. For polygon, it also extends shape, but we now make it non-sealed. That means it's all fully open again underneath polygon. Rectangle is the third branch, if you like, of subchildren, and it's now going to be sealed. So the first one we stopped, the second one we let it to be fully open, and this one now we've got controlled. So you've got the option to go either way. Now, yeah, sealed is a new keyword. It's one of it's a special keyword in that it can still be used as a. So Groovy tries to be very gentle with its keywords. You can still use it as a key to a map and in lots of other places. You can still use it as a variable name, I think. So there's lots of, so even though it's a new keyword, it shouldn't impact existing code except in edge cases. Okay, now one difference between Groovy and Java, the whole non-sealed keyword there, we allow you to elide that. You can leave that out. So in Java, what's the implication of putting non-sealed on the class? It's the same as if you had left it out in terms of what the modifiers of that class are going to be. So we just let you leave it out. Now, Java's thinking is that it's going to be unusual to want to open it up. So since it's an unusual case, we'll force the programmer to put the non-sealed keyword in to, because we don't want the programmer to make a mistake. Whereas Groovy tends to say, well, we'll let you, we'll assume a programmer is someone who's knowledgeable, and we'll let you do things in succinct ways. And if you want to force yourself to put in the keyword, then fine, that's all good. And in fact, we'd anticipate down the track there'd be a code narc rule that would allow you to enforce a style where you always added that keyword. So then you could opt in to, if you would like to follow the Java style, you can opt in. Otherwise, we're sort of following the Scala style and leaving that out. Yeah, it is funny that non-sealed is a valid keyword. I'm still not sure that that was a good thing for, I think unsealed would have been a better choice myself personally, but the Java folk reckon they're going to have additional keywords down the track with a hyphen, a minus in them, or hyphen in them. So they wanted to get people used to it now. Okay, switch expressions. So traditionally for Groovy, at least, a switch has been a statement. So you could have a switch statement and then you'd have case branches with maybe breaks or returns in them, or you could have them falling through. Now, instead of having the colon after a case, if you put the sort of the closure or lambda parameter separator, so the minus greater than sign, that indicates that you've got a switch expression. So here I can have a switch. Here I happen to have an integer. If it's case 6 or 8, I'm going to return the string B. Otherwise, if it's case 9, I'm going to return the string C. Otherwise, I'm going to return the string Z. And obviously, if I pass a 9 as my parameter in there, C is what's going to be the result of that. So that's a switch expression. Now, Groovy's switch statements are all powerful. So if I had like an enumeration of days of the week, I can still use ranges or lists or all the other things. You can have regexes and closures and all sorts of things inside your case. The item that you're matching your case against. So you can have Monday, ... Friday, and so on, still with the minus greater than. So all of the bells and whistles you'd expect in Groovy are all there. So I can obviously take Sunday, Monday, and Friday and collect the weekend and come back with true, false on that. If you still want to use the colon syntax, you can, but if where it can be used as a switch, if it detects that this can only be an expression, like you've got it in a return statement or on the right-hand side of an equals expression, an assignment expression, then the colon, it won't care if there's a colon there, it'll still treat it as a switch, but it'll require yields to be there. So that's a way to do a sort of like a return kind of thing, but it's special to the switch statement. Okay, so that's just an alternative syntax. Most people probably won't use the colon syntax, but it's both are there if you need them. The next thing is JSR 308, which is the annotation support. So Groovy had it for methods and classes for many, many years. It's had it for parameters for quite a number of versions. It's now on type parameters as well. So if I have a list of integers, I can now put an annotation on the integer, and that's an annotation on the type. So here I'm using jQuick, which is a great thing for doing property-based testing. And what I'm saying here is I'm creating a test case, and what for all means I want you to run this for a whole bunch of different cases, so 1,000 or 10,000 or whatever cases. I want you to create lists of size 5. I want all the elements in the list to be unique, and it's going to be a list of integers. So create me lists of integers, lists of unique integers, and I want all the integers that you create to be between 0 and 10. So previously you could put in that int range between 0 and 10, and the Groovy grammar allowed you to put it in there, but that never made it into the bytecode. So that's now there. So that's all fully supported, and that opens up some good tooling. So jQuick is just one example. Another example is the Java Bean validation framework. So the latest version of that has a whole bunch of annotations. So here I'm creating a class car with 3 properties: a string, the make of the car, like the model, the number of seats, and a list of owners, which is strings. And I can say that the make can't be null, so it's not null, and it's got a size between 2 and 14. I don't know why I put those restrictions on the property, but maybe I've got a database where it's got a maximum size in the database for storing these things. I'm not sure why I don't want to limit myself to 14, but I guess Tesla fits in 14, so maybe we're in good shape. I don't know. Number of seats is an integer, and you can't have 0 seats in a car, so we're not going to force you to stand up in your driverless car or whatever. Or maybe you could lie down. Maybe you could have a bed instead of a seat. I don't know. But anyway, in this case here, we're not going to let you not have a seat, and we're not going to allow blank owners. So you can't have a stolen car and sort of blank out all the owners somehow. We're going to keep the list of owners, so they can't have any blank strings. So that's now all fully supported in the bytecode. So the Bean validation framework works nicely as well. Okay, quickly going on to the libraries and tooling. So this is just using Groovy's match operator. So I've got New Year's Eve, so it's a string containing a date-like thing. And I'm going to start matching it against some sort of date with 4 digits. And I'm going to keep that as a group, and then a hyphen, and then a date of 1 or 2 digits as another group. And I'm going to keep that, and so on. What's going to happen when I run this? I'm actually going to get a runtime exception because I left off the last round bracket. So at runtime, when I run this, I'll get a pattern syntax exception. And similarly, if I've left off one of the round braces, but if I left off one of the curly braces, or I did some invalid backslash or whatever, I'll get things at runtime. If I use the regex checker, I'll get that feedback at compile time. So it's good to get that feedback early. And so this is where Groovy's type extensions allow you to be stricter typing than Java if you want, or looser typing, falling back to dynamic typing if you want. Groovy lets you go either way. And you can go use that regex checker. So it's at the moment it's in an optional module, so it won't be there automatically, but you can add it in. And then at the moment, it's not added automatically. You can use Groovy's compiler configuration integration to make this addition transparent if you wish. I won't go into the details for that, but you can basically force this to occur all the time if you want. But for us, we're just going to do it just over one particular method in our code. So it'll, obviously, the more checkers you had, the slower your compiler is going to be because it's doing additional checking. For us, we're just going to have that slowness just over this one method. So there, yes, that's in the type checker module. So we're anticipate adding more checkers. We've got some more in mind, but at the moment, it's just the regex checker. We're sort of just shaking out the trees, making sure people are comfortable with this this style of doing things. Now, I showed you using that with the match operator, but it's right across all the different supports. So the pattern syntax, it supports repetition quantifier braces, closing group bracketing, dangling question mark. So question mark means zero or more of the thing preceding it. But if I've got nothing preceding it, then it gets a bit confused. So it picks out all of these errors and it picks them out whether I'm using all of Groovy's shorthands or I'm using the Java APIs directly. Okay, so you can see all the different flavors of things there that get picked out. Okay, when you're using groups, if you use the bad group numbers and it's there as a constant, it can detect that as well. There's a built-in bunch of macro methods. So if in your code, you always, I use IntelliJ quite a lot, and it's got you can go SOUT-V and it'll print out the name of a variable and then its value as a sort of like a poor man's debugging mechanism. You can actually embed that sort of functionality into your language using NV. So it'll give you a name and a variable of the list of things that you give it. So I can do various, I can use instead of calling the normal NV calls toString on the list of supplied variables, but NVI will call the inspect method. So that has a slightly different syntax, which is like a range, for instance, will give you a more compact version. And there's also a dump flavor as well. So that's all kind of nice. And again, we anticipate more macro methods over time. So you can go and store your data and configuration in things like XML, in things like JSON, things like YAML. And if that's not enough for you, we now support TOML as well, and you can both build it and parse it. So I've just got little examples of that. I won't go into all the details. So it's showing building and parsing. There's a thing called Java Shell. So many of you have probably used Groovy Shell. What Groovy Shell lets you do is work with snippets of Groovy code. And it's very, very configurable. So you can go and tweak the Groovy Shell so I mentioned before the regex checker. I can make I can go create a new Groovy Shell that compiles Groovy code and always applies the regex checker, or always applies compile static. So the Groovy Shell is sort of a window, if you like, into the Groovy compiler that's available to enact at runtime. We can now do the same thing with the Java Shell. Now, you might wonder, why are we doing this? Shouldn't this be some functionality that comes with Java? Well, maybe, but Groovy gets used in a lot of contexts where you're scripting, and it's just good to be able to do both Java and Groovy snippets. And we use this functionality ourselves when we go and do things like I've shown you seal classes. If we're writing a test case, we want to generate a test case for Groovy and a test case for Java. And we can now use the Groovy Shell and a Java Shell to go and generate test cases at runtime that might go and look for, let's do all the cases. Let's do interfaces, let's do classes, let's do abstract classes and so on. Some like trait might only be on the Groovy Shell, but all the ones that are applicable to Java, we'll create them for the Java Shell. And then we'll run those snippets for both Groovy and Java and see if we get the same results. So when we're comparing the two languages and we're wanting to provide like-for-like functionality, this sort of having the little Java shell is some useful functionality for us. And we think it might be useful for others as well. So we're making it available. It's a sort of incubating status. We'll see what people think of it, but we think it's got some good value. And since we had it there, we just added it to the Groovy console. You can now go run as Java, for instance, run selection as Java, compile as Java. So there's a bunch of extra places where it's going to use that Java shell underneath the covers, or you can use it yourself in your own programming. So that's a nice little little bell and whistle. Ranges have been improved. So you always had 1 up to 5, or 1 up to but not including 5. So that was inclusive, or what we used to call exclusive. But now it's right exclusive. We've now got left exclusive and full exclusive as well. So we want numbers between 1 and 5, but not including 1, and between 1 and 5, but not including 1 or 5. So you've now got all 3, support for all 3 of those. And obviously you've got a class, a range class underneath all of these that you can use as well directly, which backs that pretty syntactic sugar. AST Transforms is the last big topic. Now, just a refresher, anyone listening here who's not familiar with AST Transforms, before I start diving down lots of details. AST Transforms is it's a compile time metaprogramming capability. Now, what's that mean? Here's a Groovy class, and it's actually just got 3 properties. And what the Groovy compiler does when it compiles that up is it does a few things for you for free. So the equivalent Java, it would have 3 private backing fields for those properties, and it would have getters and setters for each of those properties. So that's not all. You don't necessarily want all classes to support that style, but that Java Bean style is still one of the common styles that gets used, and Groovy's got good support for that via its properties. And what compile time metaprogramming is a way to interact with the compiler and say, oh, I want you to do something slightly different to normal when you're compiling this up. So for instance, if I put toString on the class, it'll be the same as before, but it'll now have a toString method that's based on the author's title and publication date properties. So it'll make a nice pretty toString that knows about those 3 properties. So it's a way of interacting with the compile time process to get more things done for us. So it's often things that are design patterns or particular idioms that you might have, we can bake into one of these AST transforms. So I can get a little bit more sophisticated. So I can have an immutable. So when I create a book instance, I'll never be able to change it anymore. I might have a way to create a version of one of them, though, a new version of one based on existing properties. That's what the copy with might help me with. I might want to sort lists of books. I might want to be able to represent this in some sort of external form, save it away to a file, serialize it out. I might want special support for, so instead of just getting normal getters and setters, I might want getters and setters that let me specify an index of a particular author I'm after. So I can use these AST transforms and it generates even more code. So it'll generate me 500 lines of backing code. So that's what the AST transforms is about. It's compile time metaprogramming. It all happens at compilation time, and I get classes that Java can make use of as well. So Java can call the toString or the special index getter or whatever it might be, the sort methods. So that's the property. Groovy's always given us new ones of these over time. So it's started off with a very small number, and we keep finding, I keep thinking we will have reached the final number of these that we could ever support. Surely we've got every design pattern covered now. We've got every idiom covered. There can't be any more, but we seem to keep finding more things that people will find useful. And obviously as Java's evolving, there's places where new things pop up where we can make things on the JDK simpler and better and more productive for users. So we've got more things. So yes, we've got more things. That's the list of them over on the right-hand side. I'm not going to go through all of them, just to pick out a couple. There's a thing called POJO, so plain old Java object. So if you recall, compile static creates classes that are more like Java classes than normal dynamic ones. So Groovy's got a dynamic nature and a static nature. Put compile static on a class and it becomes closer to a Java class. But there's still a whole bunch of stuff inside that class. It's still got a meta class and a bunch of other stuff. There's still a bunch of stuff that's in there that requires you, for instance, to have the Groovy jar on your, if nothing else, have the Groovy jar on your class path at runtime. Now you can add POJO as well as compile static. It should really imply the other, but at the moment they're just sort of separate. And it creates a class that in most cases, well, in many cases, doesn't require the Groovy runtime class to be there at all when you're using the class. So it goes even further and says, yes, I'm going even further and trying to make this not rely on any of the mechanisms that are inside Groovy's runtime jar. If you like, it's a way of trying to do Lombok style processing where the result of there's only certain AST transforms work in combination with POJO, and those AST transforms become Lombok style things in that I can use a full language, not just a Lombok preprocessor, and I can create Java classes that you can then go and use in Java land without the Groovy runtime being there, but all of the generated code that you'd expect to have there in Java land's all been generated for me. So I can still have the nice succinct styling that Groovy gives me. Okay, if you recall, so going back in history, there's an immutable annotation that we, in Groovy 2.5, we teased out all the bits of that, made it a bunch of fine-grained parts. And the reason we did that was that people might want to mix and match those fine-grained parts in different ways. We were getting lots of people to say, oh, I like immutable, but can you add this feature or that feature or whatever? So we're letting you mix and match the more fine-grained features yourself. And it turns out that that allows us to support a record type. Now this isn't exactly the same as records in Java just yet. That's something that's on for future research, but it creates something that's very, very close to records in Java land. So it produces a class that's implicitly final, it has a private final field, first name, has a default constructor, has a default serial version UID, all the things that you'd expect in a Java record. All of those are in one of these record types. At the moment, it's not a native record. That's something on our future list. And the syntax down the bottom is something that we're looking at. Before we get that far, we'll work out how we're going to support native records as well. But you can start playing with that and getting most of the benefits of record types just with plain old classes, and the compiler will do all the right things to make it look and feel the same. We've added, there used to be a thing called GContracts, an external third-party library, and it was starting to be not maintained, but we think it's still, the whole design by contract paradigm has still got there's use cases where it's still a very, very useful way of doing things. So you can put an invariant on classes, you can put preconditions and postconditions, and that's an optional module that you can use and make use of if you like. Okay, the final thing I'm going to mention is GK enhancements. So these are extension methods where we add extra bells and whistles. So as Java evolves, we try to, anywhere where there's pain points and we can make things more simpler or more productive for our users, we tweak them and GDK enhancements. One of the ways we do that. Just going to show you a couple. There's more than what I've got listed here, and there's probably more before we have the final version of Groovy 4 come out. But just show you a couple of them. There's a concat method inside the stream API. In Groovy, you'd expect to be able to use plus, so we support things like that. You can, if your JDK supports it, you can print out the process ID of your running process and things like that. So there's a bunch of little things like that that we've added that you can make use of, and there's some more that I haven't listed there. But that's just to show you that we're continuing evolving that side of Groovy as well. Okay, what else is coming down the track? Well, we're still looking at additional switch destructuring and pattern matching, potentially the instance of pattern matching. So if you're using flow typing, which is what Groovy supports, then the instance of pattern matching that recent versions of Java have had in preview, or now in full versions, in the very latest versions, that is less relevant, but we may support that style, and there might be places where it could be useful as well. I showed you the regex type checker, but there's a whole bunch of additional ones that we have in mind, checking whether my functions are pure functions, checking whether instead of having, doing smarter things without non-null or not null and so on. Writing module definitions in Groovy. So if you're into the Java module system, Groovy lets you mix and match between Java and Groovy, so you can go write those in Java right now, but maybe it's nice to write them in Groovy as well. A couple of things that some of these may make before we do the final release of 4, we just haven't got around to them yet, and depending on when the RCs come out, some of these may or may not get in there. AST transforms, there is a priority. They get run by phase. Depending on what phase they're in, it will determine when they get run. And then within a phase, the order in which they appear controls which ones get run first. But sometimes you don't necessarily want the order in which they appear to be the same order as they get run if they're all in the same phase. And so we might have a mechanism that lets you specify that priority. So that may make it for Groovy 4. We'll see how we go. That's we still need to get a full working prototype for that. It's been in earlier versions of things like Griffin, and I think even early versions of Grails may have had something similar to that, but there's some things that we want that weren't in some of those early prototypes. We may provide, so there is things like HTTP Builder and HTTP Builder NG, which a lot of people use. And if you're going to be using versions of JDK earlier than JDK 11, then by all means, we recommend you go use that. But we might supply something that looks like that, but has the JDK 11 HTTP client underneath it. It's just often in the sort of scripting that Groovy gets used for, there's lots of places where the just getting information from clients is being a HTTP client is something that's very, very common. So it'd be nice if we just had some really good built-in support for that. One of the things that you would get out of the box. It'll probably be an optional module, but it'll be there for anyone who wants to make use of it. And as I said, for records, we don't have the native records yet, or that record syntactic sugar with a record keyword looking thing. They may come at some point. Okay, so that's all I wanted to cover. I think I've got about 5 minutes left for questions. So
thank you so much, Paul. I appreciate it. It looks like there's some exciting things coming in Groovy 4, and we cannot wait for that. Yep, like you said, we have a couple minutes and there are a few questions, so I'll grab a few of those now. There is one, can we use or redefine at record type with Groovy 2.5?
Okay, oh, it's further down. Okay, I've got the list here as well, so I'm just.
Oh, you can see. Okay, great.
I'm just cross-checking. So I did answer a couple at the top, but I'll come down and see how we go. I'll answer these live and see how we get through. So no, you can't use record type with Groovy 2.5. or in fact, even Groovy 3 at the moment. So if I'll just quickly come back to the slide and see the very first annotation there, record base. That's not in Groovy 2.5. All the other things, pretty much all the other things are. Pojo won't be there either. So you could go and make your own record-like thing back in Groovy 2.5 land, but it won't be exactly the same as record type. But you can make your own using an annotation collector that would be very, very similar. And that might be a useful thing if you're back on Groovy 2.5. So let's see, sealed is a new keyword, but it's a simplified keyword. I'm pretty sure I've got the sealed compilation unit thing right. It's using a full, it converts it, the Lambda style switch expression. The whole switch expression gets converted into a closure, in fact, and in each case branch, I think that's also a closure. So yes, there's closures get used as how the backing mechanism behind how that gets done. Okay, ETA for Groovy 4. Well, we've expecting our release candidates sometime in the next month or two. And if we get good feedback, I'd like it sooner than that, but obviously there's a few things we haven't finished, and we're an open source project, and so we get things done when the community gets them done. And I'll probably work on some of them myself, but there'll be other people potentially involved, so it'll be done when it's done. Hopefully we'll have RCs out at the latest in a month or two, and then the final one will depend on feedback. If we get good feedback on the RCs, there's no reason why we couldn't have a short number of weeks after that. So it could be imminent, but if we get lots of feedback, then we'll take that into consideration, and we'll factor that in. Does Groovy integrated query also come with yield like C#? Not exactly the same as C#, but I'll have to look into if I'll have to take that offline. I haven't memorized all of the keywords on the Groovy integrated query. Daniel would be able to tell you off the top of his head. Okay, so there's a let's see. So yeah, type checkers is one of the optional modules. Will Groovy 3 still be maintained? Yes, I'm expecting Groovy 3. We're still, if we get an emergency security fix, we'll still go way back to 2.4 and put out new versions. 2.5 again, we're releasing new versions of that. We only in the last short little while, in the last few weeks. I'd expect less and less 2.5s. 3, I'm expecting to be supported for quite some time, but yes, we want 4 to be the main focus going forward. So is there any plan to make Groovy fully statically compiled? Well, Groovy's got a very strong dynamic nature and a very strong static nature, so we think it's good to keep both strong. So I don't think we necessarily want to be a competitor to Kotlin or Java. We're trying to be a complement to Java in that sense. How is Graal compatibility? That's something that we need to spend more time on. Some people have gone and played with it. I believe that it's no worse. Oops, it's telling me I need to wrap up shortly. Does Groovy 4 use Java modules internally? Not yet. It's designed to be fully compatible, but it doesn't actually have the module info class information embedded in anywhere at this point. Yep, there's a feedback about the new parser being slower. We're working on that. So we're we're working on how we can increase performance. We've done some little bits to increase performance. There's more that we'll be able to do, so we'll keep working on that. Is there a minimum Java version for Groovy 4? It's still JDK 8. Groovy 3 does support JDK 17 and maybe 18. 4 supports 17 and the early access versions of 18. You may not get as good a support for JDK 17 on Groovy 3. Okay. Did you remove the grab annotation? No, the grab annotation is still there. And I've already answered the top one. There are the regex checkers. Yep. Any plan to support, bring back support for Groovy for Android? I'd really love that, but I don't think anyone is working on that. I think actually, once you get to Groovy 4 and you have the Podro method there would be a whole new opportunity to move in that direction. But I don't know anyone who would be motivated to do so. But I would certainly support it if someone was keen, and it's certainly something that we can look at. And if it ends up being something that's got legs, we can look for ways to try to make more people interested and sort of drive that. My suspicion is that there is things like Kotlin has got the mind share at the moment. We'd have to work on the mind share as much as the technical sides to reverse that. Okay, what's in the roadmap for Groovy 5? Well, we haven't thought a lot about the roadmap for Groovy 5, but certainly some of the things that were mentioned in the, oops, and I don't know whether you've lost the window or not, but I'll just go back to that. I don't know whether you're seeing the full thing or not.
Yeah,
okay.
We can see your screen.
Excellent. So certainly things under smarter type checking, there'll be some of that won't make 4 and some of that will go into 5. So we're actually thinking that because of Groovy's extensible type checking, there's some really, really powerful things that we can do in that space. So at the moment, you've got to go and put not null and things like that in your code. A lot of the research in this space, they actually go and work all that out for you. So you don't need to go and put stuff like that in your code anymore. So there's certainly a whole lot of stuff in that space. Because Java's been evolving a lot more quickly, there's a whole lot of things that are cropping up now that where we think we can see some extra value add, and we'll target some of that for Groovy 5. But at the moment, we're just keen to get Groovy 4 out the door. Okay, so I think I've used my time up, and I think we've got all the questions answered.
Got them all answered. Yeah.
So thanks very much for attending.
Yeah. Thank you so much, and thanks everyone. Thanks, Paul. Talk to everyone later.
Thanks. Bye.